Okay. Good afternoon. Happy April Fool's Day, everybody. So much has happened today, huh? And happy birthday. So, it's the birthday boy. 𝖘𝖔𝖈𝖎𝖆𝖕𝖎𝖙𝖘 is your birthday, is that right? So, because it is, I might tell you a little happy birthday thing. So, because the style of today's activity is like a children's classroom, we're gonna be making we're gonna be indulging that fact a bit. So everybody get up and we're gonna sing happy birthday to 𝖘𝖔𝖈𝖎𝖃. Okay, happy birthday to you, happy birthday something you, yay. So happy birthday. You're 1 year older. You know what? I happen to have my birthday once a year too. So, it's gonna be coming up in the summer, so that's gonna be nice. So, lots of things happened today. We went to the moon, guys. We're going to the moon. So, I had actually no idea what the plan is for the thing, for the Artemis 2 mission. So I was actually pretty excited just to see everyone's enthusiasm, because then they were gonna fill me in on what the deal is. So very cool. We're gonna go to the moon to make sure it's still there. That's why we're going there. And then I believe the next mission is gonna be in 2028. Is that right? So that's a long ways away. Going around and study things. Next mission is landing, if I recall correctly. Yeah, we are excited for that. We're gonna bring home space rocks, and they're gonna mine for some things. They're gonna be playing Minecraft on the moon, guys. So really cool. I'm really excited to see the cool technology they use for that mission. And hopefully right now the astronauts aren't bored. I can imagine a 10-day trip out in space is a little boring, isn't it? What do you think they do for fun? What do you think they're doing right now, while they wait for the next few days? Taking lots of pictures, lots of selfies, huh? Lots of videos, and they log into their Microsoft accounts from there. Well, they have they gotta check their teams. You know, they gotta make sure that they're on task. You gotta reach back to Houston and say, oh yeah, I got my dailies to do, hold on. Let me just log in. So, that's exactly what they're doing. I was suggesting they were playing cards. Probably like, if you were to play one deck of cards, like playing cards. What kind of games do you guys know of? There's this one I did I did a research undergrad experience, and it was called Oh Hell. It was pretty interesting. I can probably make a mock-up of it and make other people play, but I think it's an Australian game. Houston, can you help me with my verification code? I keep trying to log in, but it's saying my IP address isn't good. Doesn't recognize it. Imagine they do that. So let's see. So today's gonna be a little chill, but we are gonna be doing some worksheets. So the worksheets I have in mind, we are gonna be designing them live, and I'm welcome for input, because the idea is that you can always actually give them to another person. They're not gonna be too hard. They're not going to be impossible. It's where you need to learn group theory or probability theory or anything ridiculous. We're going to be using basic, common math things, but we're going to make them extremely hard on purpose. So, we'll see. If you've heard of the game, but you don't remember how to play it, it's so fun. You have those, and then you have trump cards, and then at some point you have the wizard and the jester, and then And then if the wizard and the jester are in play, that means you win. Or the winner loses and the loser wins. That's good. What are we doing? So, we are going to be designing our worksheets. We are going to be using this amazing modern website called Canva to design our joke math problems. So our math worksheets are going to be along the style of, oh no, help Sierpinski, and I'm going to do this one, help Sierpinski get through the maze. And then it's going to be, you know, a fractal or something silly, right? So some of them will be impossible to do. Some of them will have a joke where you will need to, you don't have enough space to actually do the problem, which is, you know, funny. And then there are some other ones that we can do that are, you know, probably arithmetic or Pythagorean theorem or something. Help, you need to help Pythagoras create the Pythagorean theorem. Prove it. Is that the run? Play Phano? I'm curious. If that's the one, then I'd be down for it. So what is this here? Competition leaderboards. What is this one about? Is this the one I was talking about? No, not that kind of game. It was like cards and stuff. So let us, I'll look into this one. This looks pretty interesting. Card games. Oh, that's a really fun one. So I guess I could show this off real quick. So let's move over to the gaming section. I don't have Blender up at all. The proof is trivial. These are great. Let's see. So Firefox, I want you to find the theorem of the day, and I'm gonna pop it up real quick. Please be right. Yes. Okay. Cool. So what you're sending me right now, these are some pretty interesting websites. One of the answers can be RNG'd from there. So this is the truth. The proof is trivial. Just biject it to compact multisets, to a compact multiset whose elements are indecisible Cayley graphs. Cayley graphs. I remember those. One of the answers can be RNG'd. So if I reload it, oh, okay, that's cool. Just view the problem as a total Cayley graph whose elements are universal random variables. Is it all just Cayley graphs? No, okay, good. A proof is trivial. Just biject it to a pointless Lie algebra whose elements are context-free. 7 chains. Ah. And then this other one was a card game that you showed me. So, let's see what it is. Drawing inspiration from a strategic cadence of TCGs and the pure minimalism of chess, Phano distills competitive play in its most elegant form. Each match unfolds as a duel of insight, timing, and positional finesse. With rules that welcome new players and depth that challenges experts, Phano offers a refined experience where mastery emerges through subtle decisions involving strategy. I'll have to give this one a shot. Maybe we can do this one with some other people or another time. 7 chain, is that a Puyo reference? Don't worry about it, Penbu. Yes, it is. It is a pen. It's a reference, of course. So I don't want to lag on too much just yet. So we're gonna go ahead and get started with the idea. You're free to play. Make a channel point redeem. I'll do that. I swear to you. So tomorrow I have some time. Today I was watching the Artemis mission. Earlier I worked, and then tomorrow I happen to have some time. I gotta get those freaking redeems doing. If only somebody more competent than me could discover how to do such a thing. But surely not. I'll reach out to some friends, and I'll see if I can get that working soon, because I really do want it to work. Because otherwise, how else am I gonna have you guys play with me? So maybe we can play this on our own time if you want, outside of stream, because I'd be down to just, you know, shoot it and play around with this. I do also want to cover the theorem of the day, because I noticed that the calendar on this one is actually a day ahead, which means they're probably based in somewhere not here. Probably who's ahead of us already? Who's probably a Kiwi website or Australian website. So that's probably why. And I wonder what the deal is with all the towels. There's lots of towels in this website for whatever reason. Got a shower. Thank you very much for letting me know. So today's theorem of the day, let's take a look. UTC would also be ahead, I think. I guess so, huh? It's probably automatic. So it probably just starts with the new day, and that makes sense. So let's cover the theorem of the day and then get straight into our worksheet making. So we have the Lutz-Nagel theorem. The Lutz-Nagel theorem. For the elliptic curve, y squared is x cubed, x squared, x, and c, where a, b, and c are integers, and having non-zero discriminant function d equal to this stuff, let p be a rational point on a finite order greater than 1. We're already in the weeds with this one. Then x and y are integers, and either y divides d or y is equal to 0, and p has order 2. Any analysis people in the chat? This looks like a lot, actually. An elliptic curve. I don't think I've ever encountered something like this before. This looks like either like a geometry thing, or maybe a real analysis thing, or a multivariable thing. Well, it's 2D, so it can't necessarily be multivariable. But basically what it says is that this special condition and this special condition makes it so that the x and y's are integers, and they divide or they're 0. So they're rational points on elliptic curves. You only know elliptic curves from cryptography. I guess that's probably a point of it. When I think of like polynomials like this, I'm thinking of like Diophantine equations. So number theory, I want integers as my coefficients, and I do not want them to be other numbers. And if this happens to be the case, it looks like a geometric, like a dense one. Pretty unique for what it's covering. Structure of a group defined by an elliptic curve is largely determined by the points of finite order. The importance of this group is amply demonstrated by Andrew Wiles's resolution of Fermat's last theorem. Oh, okay, so it's a consequence following the theorem, by proving that all rational elliptic curves define modular forms. The Lutz-Nagel theorem, discovered in the 1930s, is by Elizabeth Lutz in France, and Tigriff, there's no vowels, Nagel of Norway, and thus an indispensable tool in algebraic number theory. Trivial stuff. What is it? The proof is trivial. Let's reload it. The proof is trivial. Just project it twice to a twice differentiable hypergraph whose elements are orientable Dynkin systems. Yeah, of course. I'm gonna keep this right here. So, trivial stuff. Pretty cool. I like learning about the existence of some of these things as opposed to really understanding it. As long as you know it exists, the proof it can be neglected for now. Theorems are nice because you could just say, oh, this is true, and that's all you need to know right now. Just cool. Alright, you guys excited for making math equations? Making math problems? So, I made one earlier. I was writing this up in Canva using a template, but this one I thought was pretty funny. This is to prove the points of what I want. So I took an existing counting template. So count your numbers. And they're little acorns here. So I thought it looked cute if, let's say, it was count your Fibonacci numbers. So there's some pre-fillers in right now. Fill in the next 50 spaces with your Fibonacci numbers. Hint, add the last 2 numbers. You guys know how to do the Fibonacci sequence, right? You have to start with 2 and 3. Then the next number is the sum of 2 and 3, which is going to be 5. So we would fill in 5 right here. Now, the joke here is going to come from the fact that pretty soon the numbers just blow up. So there's absolutely no way you can realistically write all these numbers out. Like, for example, let's go back to the theorem of the day. I like the little graphic it has with this. So the first few numbers are pretty nice. You got 2, 3, 5, 8, 13, 21, 34, 55. And then after some more in here, you notice that there are some big numbers there. And if I go ahead and look up the first 50 Fibonacci numbers, there's not going to be enough space to actually write it out, which is why I think it's hilarious. So, yeah, because take a look. The first 50, it already goes into like millions of digits. I'm sorry, not millions. Oh, goodness. A few. Let's see. About like 15 digits or so. So the joke here is that even though you can prepare a worksheet for it, it's not gonna work out. So it's a fool's errand, which is this is the style that I'm going for. So let me actually move this one over. So let's get some of the next few ones so that, you know, a student could realistically find the next few, right? So we have 2, 3, 5, 8, 13, 21, 34, 55. So 5, 8, 13, 21, and then I'll do 34. 34 would be right here. 34. All right. So my question, if you guys can help me think of something funny too, that would be good, right? So 2, 3, 5, 8, 13, 21, 34, and then I would leave the rest of this and it would be, again, a fool's errand for fun. So that's the idea we're going for. I have another idea. We can use a maze problem. Basically what we're doing is we're making like a kid's meal activity sheet. So we have tons of different things to do so that it follows a theme, you know. But the joke is just they're all either impossible to do or it's just ridiculous to do. So maybe we could do something with a triangle. For those of you who don't know, are you familiar with what's called the triangle identity? Or the triangle inequality, excuse me. Triangle inequality. So I suppose it's a theorem. If you're not familiar, do not worry. Oh, look, there's a very nice IXL sheet that shows us it. So, functionally what it is, I suppose I can use let's look at Wolfram Alpha's definition. I guess this might not be the correct one. Triangle inequality, that's not what I meant. Excuse me. I know it just might be. Anyways, here's what you have. You have a triangle. And let me pull this up in Blender so I can show you guys. Suppose you have a triangle. And you want to know whether it actually makes a triangle. You have only the sides. If I tell you the sides, you got to discover whether or not it really is a possible triangle to make. So if I give you some numbers, let's say you can make an equilateral triangle. So any 3 of the same sticks I give you, and you have to make it together, then that will make a triangle. However, you cannot under specific circumstances. So once it blows up, I'll show you real quick. So the joke I'm going for is you're gonna have a set of sides and none of them will be able to make a triangle. So let me show that real quick. So we could always make a triangle like this. So I'm gonna make a 3-sided triangle, a 3-sided circle, and that is that's what we want, right? So the cool thing about this is you can find out the side lengths. So if I split them off, the sum of the 2 sides are always going to be bigger than the sum of the 3 sides, than the 3rd side. Oh, I meant to split it. So, if you like an actual question on a worksheet posted on Reddit, there more than likely is, because it's a very... I think 𝖈𝖊𝖉𝖎𝖙𝖘 covered a video on it just recently, not too long ago. So let me split this real quick. So yeah, the theorem states that the legs of the 2 other sides must be bigger than the 3rd side. Okay? And you guys can tell me, does this in fact look like it's longer than the other 2? And let me actually separate these and give it a skin. What? It's probably where you got it from. Yes. Okay, let me separate these all again. Yeah, I'm not going to do that. I thought I was going to be quick. Okay, anyways. That is the case with all of these ones. So when we have another triangle, let me make another one real quick. Let's say I want a right triangle. So I'm delete this face. This vertex is gone. And then I have a 3rd one. This is a right triangle, is it not? So look what happens when I split up all my edges, okay? So even though we understand the hypotenuse is the longest side of the triangle, something special happens when we break off the other legs. What did I say just earlier? So, you know, a squared my microphone broke. Was I still talking? We're gonna make a joke where, no matter what sides you use, you won't be able to make a triangle. So the joke is gonna be, oh, can you make a triangle with this long and this long and this long? How is that? Kind of nerdy, kind of boring, but it's a triangle fact, and I think it's kind of fun. So let's go back over here. We're not going to use the triangle inequality, not right now at least. We're going to create a new page. So, oh, and it looks like we have a ad coming up, so don't worry. Let me look for templates. So let's look for triangles. Okay. We don't need to classify them. And there's some fun ones. There's some fun ones, right? So we can like remake some of these ones to make it even more ridiculous. So yeah, Pythagoras theorem. Which, by the way, why is it called? I understand why it is called Pythagoras' theorem, but I've always learned it as Pythagorean theorem. Has anybody used this modern description of it? Pythagoras' theorem. I think people in Europe also pronounce it that way, or non-American. Because I prefer Pythagorean theorem. Let me see. Yeah, and then some of them I have to buy, and I'm not going to bother with that. So we'll reuse what we have. So I like this setup. In Italy, it's like that. Il teorema di Pitagora. I don't have an Italian accent. From South America, so neither, I guess. Wasn't it like, I guess, hold on. I know Spanish, but I'm not like fluent in Spanish. Anyways, that's gonna happen in just a second. Let me set up this question. You also, I think it's also Pythagorean theorem in Canada too. You read Italian pretty well. Thank you. I am Il teorema di Pitagora. I mean, it's functionally like Spanish. So with these sides. So what's the picture that they have here? Oh, it's like a whole picture. Okay. It's fine. We will get rid of it. So let me create a shape. I need it to be white. And then it's going to go all the way to the back. Would it be funny to just do like a stream where I have to like speak a certain language as best as I can to communicate math? I really want to try that in Japanese, but I don't know enough Japanese to even begin with to try anything. In Spanish should be a little easier because I do know a bit more of it. French would probably be funny though. I don't know any French. What layer is this on? Come on. Okay. Passion in Japanese. I actually, okay, there's so many different words in so many different phrases for different numbers that I probably wouldn't even know where to start with it unless I am thoroughly focusing on the reading, and practicing my language in it. So, yeah, I want to go to Japan soon too. I was gonna be no, I can say it. I meant to apply as a English teacher to get that ball rolling. Probably more than you think. 本当ですか? 俺は死の男女平等ながもの。𝖘𝖔𝖈𝖎𝖃の賢治を生じ。𝖘𝖔𝖈𝖎𝖃男のくせにと書いちゃうやからはうるさない人間だ. That's not like proper. I learned that from Konosuba. Spent an hour just learning that. It's Kazuma's gender equality rant. Weeb. Yeah. I mean, yeah. So I was just playing it on repeat and trying to get it as close as possible, and I did not have a slowdown feature, so I was just like earring it. So, let's see. Okay, so the joke here, to make this work, can I draw stuff? To make this work, I need sides that don't add up to more than the third side. So, give me a number, something like, single digits. I'll do that for problem 1 here, and then I'll fix that for problem 2 and 3. So I guess, but okay, hold on. Let me think about how I want to arrange this real quick. I want to do, maybe it should be a cutout activity. What do you think? Because the joke is that then you actually have physical like pieces, and then you can't just use them. So actually, I think I'll do that. Let me do a cutout activity. So let me check on my templates again. I'm gonna do a cutout. So not like this, not like this. Have you done questions like these before? Yeah, this is where I found the numbered one. You're walking alone in the dark streets of Bologna. Towards the bus station. Going back home for Easter holidays. Yee. That's pleasant. Make sure you don't get shanked. Or what is it they do in Italy? Scam you. You got this. Be safe. Let us know if anything bad happens. Let's see. There's tons of questions right here. Hello again. We are making a triangle cutout question. So, are you familiar? Bologna is safe? I hope so. It's pretty good on sandwiches. So we are doing a triangle cutout question. So the student will have to cut out the triangle pieces, the 3 sides of their triangle. The joke I'm going for is, instead of we exploit the fact that you have to have a longer side. So even though you have equal sides, if you split up the pieces, the 2 smaller sides are bigger than the longer side, right? Otherwise, so for example, for the right triangle, that is side A, this is side B, and then side C is right here. However, even though the hypotenuse is the longest one, then yes, okay, it is the triangle inequality. Good, because I totally forgot about that. So we are gonna make 3 different sides as a cutout question, and the joke is gonna be you can't make a triangle with it, no matter how you arrange it. So that's the That's the high IQ joke right there. So, pretty dumb, but pretty funny. That's the kind of humor I like, you know? It's just like fool's errands and stuff. So I chose against this one because I was going to do it as like a visual, but cutout's better. So I'm just looking for a style I'm going for. So let's see. There's tons of pretty good ones. Repeating patterns. Oh, that's another good one I can do. So it would be like a pattern, a sequence that doesn't have predictable numbers. I do want them to actually be done. I do actually want them to be doable. I do actually want some of them to be doable. So one of them, I'm still going for like a leave the maze, but the maze is a fractal kind of joke. So that's another one I'm trying to go for. So let me actually just design my own then, because I think I can do it better than this. So first thing we need a dotted line so that we can show where our cutout area is. I also never used Canva before, so if you see me trying things out, then we're learning together. Has anybody ever like designed worksheets before? I kind of wanted to. I wanted to do some curriculum work, but stuff didn't work out. Oh, actually, I do have a good story. So, once upon a time, I wanted to do math video content, right? So, made one once or twice. That's good. That's probably your league's ahead of me. Instead of designing it all in LaTeX and stuff, I imagine doing this bit is actually kind of more fun, especially for like kids. But once upon a time, I applied for a math content creator position, and I made a whole animated video for it. They gave me a script, so I had to work with what they gave me, and I still somehow didn't get it. I think everyone is using the Manim, because they didn't specify that that's what they wanted, but they wanted an animator and they wanted somebody to make content. So I did it. So I did it all in Blender. I still have the project file. I could probably show that in stream. And I did not get the position. And my heart broke into a million pieces. So I did what any rational person does after taking an L like that. And I just decided to keep doing my own thing and be better than them. Now I get to do my own thing by making you guys watch. Pretty fun stuff. So these are going to be my 3 sides. And then, next thing I'm going to do is I need to make sure that they're long enough. Is this a rounded? Yes. So change this to be a white background with a big black border. This is actually pretty simple to use. I'm surprised about that. So the text is going to be cut out the shapes and make a triangle. Okay. So what was the nice big one? Is it bricolage? grotesque. And what was that? 32.9 fonts. Cut out the shapes and make a triangle. And everything's gonna be 32.9. See how big that is. There's so much filler space though. What can I use this bottom space for? I'm sorry, middle space. Oops. A joke where she's way harder than a normal one. I was in another person's stream. I was covering example pictures of triangles. That might work. Fit it like this or like this, and then yeah. That's a good idea. Yeah, so this is probably significantly easier because my original thought was to make like university level questions and be something stupid like, oh no, Newton had an apple fall. Help him derive the equation for gravity. It's, you know, I was gonna do that, but that's a different caliber that I actually need to like have notes prepared for. So that, you know, proof-wise and resource-wise, it'd be like little kid pictures of like, you know, 𝖘𝖔𝖈𝖎𝖆𝖕𝖎𝖙𝖘 or Newton or Leibniz. There's, you know, other math people. Make sure you cut. Oh, what's a disclaimer? Don't hurt yourself. Don't cut yourself. Use the shapes pieces below to make a triangle. Yeah, and then I'll do a little disclaimer. Handle with care. Run with scissors. Get an adult to help you with scissors. Yeah. Use the side pieces. Arrange the pieces in the space below. Maybe with glue. Yeah, they can glue it. They can glue it on. Everyone likes glue. Don't eat the glue. So I'll make this a little bit smaller so that it fits the next line. And then I have a big, giant section for it. Picture of a Tio scissors. With the kid ones. Okay, hold on. You're right. Let me see. Look for a picture. Elements. So if I look for kid scissors. Yes, here we go. Yes, okay. So, well, what? What was that noise? Oh, he wants to leave my room. Lawrence, and his name is Lawrence. Lawrence, you're free. You're welcome to leave. Go. You made such a sad crime. Go, be free. Our cats have people names. I love it. Okay. And then let me change the coloring on it. So it looks pleasant. Like grayscale or something. This is fun. Oh, that's good. Okay. Alright. Now we need some pictures of triangles. See, we have a few right here. You can put this in the background. And then you're getting sent to the back, to the shadow realm. There we go. This is starting to look fun. Alright, kids. Do you think you can do this? Okay. Send to the back. And then it's gonna have big old spot with the big So I need like a ruler or something. Ruler. Okay, I guess we can go off of this as our measurements. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I guess 16 ticks. So once we do 16 ticks, the biggest side can be 16 long. So I can use this as a ruler. Then the other ones have to be smaller than. When they add up, they cannot be 16 ticks long. So let's take a look. Maybe I can hide it up here real quick. It sounded like you were dicks. No. We need to cut them out. 16 ticks. 16 dicks. 16 sticks. No. But we're close to that. Let's see. Okay. Let us find a line. I want big lines. So we're gonna go over here. And I'll make them like a different color. Why are you lining up right here? Okay. So to make it extra particular, we're gonna make it this, and let's make it a different color. What color would you want? It's all blue right now. What color would be good? Purple. When you think of triangles, do you think of the color purple? Maybe red. Okay, move. You need to be about 1, 2, 3, 4, 5, 6, 7. 7 ticks long. Ticks. Let me duplicate this. This is just a guide for myself. So 7 ticks. The longest one I want it to be actually as long as this. So 16. And that's just outside my bounds. Should work fine. Danger zone. We're in the danger zone. Hip. Don't. Don't. What was it? What was the thing again? Don't hurt yourself if you have scissors. Don't be bad with scissors. Don't. Be very careful with scissors. Okay, that's good. Oh yeah. Discussing the favorite Vtuber Worksheets. Yeah, Classon, how's it going? I hope you're still in the chat. I apologize. Okay. Next thing we need. Now I need an arena. It's in the danger zone, so that's a big no-no. So 7 plus 9 will get us 16, which would be exactly as long as this one. So we could keep it at this. And then I can barely make this one shorter. That's good. Then I'll come up with an example. So I need tools. Okay, so this white section will be like move it. Okay, so this one's going to be our example one with a stroke width of about the same as the last one here. Right here. Example. I'm going to make it a little bigger. Then with these shapes, I'm going to make a fake one. One that works. The poor kids will not know that it's impossible. And then one last one. Okay, does this make sense? Now I just gotta move this over, and then I gotta say glue here. Okay, now to make sure that they actually do not make a triangle. I'd be over here. No, not like that. I gotta rotate. And then this one. Yeah. Let's go. Triangle inequality. Epic. It would make more sense if the example looked like the pieces they're gonna cut out. The what? Thick lines? I guess so, huh? So it's just these ones are so big that maybe, oh, I know. I'll put a border on it so that it looks like, yeah, and these need to be round too. Make the pieces look like 3 separate pieces and lines should be solid. No rounded ends. So, so move this over here. It lines up like this. And let me round these out. Let me do a slightly different shade of red, and then we'll finish this one off. Do like a pink. Pink, pastel pink, big pink, pink, pink. Like, I want them to be on it, though. Unless I can do a different shade. Yeah. This looks fine. This looks perfectly functional. Maybe I should say make sure they touch. And then let me contract this whole thing. Make sure ends touch. Capital E. Slightly smaller fonts. Dang it. Now, does that sound like too much explanation? Yeah, that's good. That's good. Yeah, I think that's good. Perfectly functional. Okay, all that to say, that was the, this will be the triangle inequality one. So whichever poor child happens to use this one, whichever college level graduate student gets this one, they won't be able to do it, which would be really funny. Okay, so let's put a stamp on this one. Big rubber stamp. This guy is done. Next one we can do. So again, last one I did was the Fibonacci one, so it's just a quick edit of the original. The joke of this one is that the numbers are going to get so big that they won't even fit inside of it. So this one here is that if you cut them out, the shapes you get are not going to be big enough. So, good joke. Good joke. Good joke, Aleph. Okay. What's another fun idea we can do? What's another idea that you guys can think of? Something elementary level. Something relatively easy. Maybe you can count. I don't know. Something ridiculous. Calculate pi, divide out the number. That'd be funny. Because you can say, oh, using a ruler, find the radius, and then find the ratio, and then the ratio is pi, and the joke is that pi doesn't end. Enter as many digits as possible. Okay, I think that's funny. So we could do a circle one where we have to enter as many numbers of pi when we divide it out. I think that'd be good. Unless you guys have another one. Yeah, this is good. Okay, so new page. Let's do another one. This one's gonna be a circle one. So we're gonna do how many digits of pi can you make? Just haven't thought of any better ones. That's all fine, as long as you're here for the ride. So let's start with a circle. Instead of this ugly puke green, we're gonna change it to another color. What color is pi? To me, it's yellow. Next, put something up here. Pi is a snake. What? Where does that come from? Let's see. Let this thing be white. A purple and black snake. Interesting. In what capacity? Are you saying it like yeah, you have no idea. No worries. Okay, never mind then. So here's what we can do. I can do a bigger circle. This one will have just an outline. Corner rounding. And no fill color. We're trying to find the fill color. Right here. Okay, next I need to make it just slightly bigger to show that this is the circumference. And the stroke is going to be a dashed line. Okay. Does this communicate pi? The circumference is good. Okay. So if I remember correctly, the pi itself is the ratio of the circumference to the diameter. Isn't that not right? So let me look for graphics about pi. Totally right. Then pie chart. I was looking for fractal stuff. So I'm gonna have little pies everywhere around it. A hidden pie. And the fact that the ratio is constant over all possible circles makes it cool. Yeah, because it's a scalar. If you increase the how much the radius changes, or I suppose the diameter still. Yeah, it increases at the same rate as the circumference. So related rates means that the constant of proportionality is still just pi. Which is pretty cool. So let me change this color. How come you're this color? Apply colors to page. That's not what I want. Not totally true. I'm spherical geometry, hyperbolic. No, that does have a difference, I believe. In two-dimensional, it's the constant. For those dimensions, I think there is a proportion, a different kind of proportion, but it's different. Let's put something else on here. Add some text. What should this one be called? Because I can also do problems with, let's say, characters. So we could always say like, oh, Timmy needs to go around a perimeter. Amanda is cutting right through it or something. So you could always do problems with like who did the better thing, or who did the longer thing, who did the faster thing, you know? If Amanda's on a non-Euclidean geometric sphere, non-locally Euclidean, how long is the geodesic, or something stupid? So let's make this big. Shall this be called? Okay. Help find the ratio. Oop. Calculate the best answer in decimal. So it's gonna be a fool's errand to not stop dividing. So the joke is that they're gonna start out with some numbers and then they have to divide it out. But now I think about it, even with a unit square, a unit circle, well, I suppose I can do it this way. I can have the circumference just be called an integer. So I could say like it takes 5 yards to walk around it. But using a ruler, a student will need to calculate the radius and then divide the numbers out, or the diameter. And they have to use the best ruler possible. So it's up to the ruler to... I feel like that's a little lame. So it could still work, but not the same way that I'm thinking of. Okay, imagine drawing a big circle on a planet Earth with a center Oh, okay. That's a better idea. So if we say, Earth. Yeah. Wait, what? Then with the center of the North Pole and the radius as big as a quarter of the circumference of Earth, then the circle you draw will be the equator. And the ratio diameter, just the ratio of circumference diameter would equal 2. Pi is equal to, totally. So I'll do the planets. So I'll replace this with the planet, and we can change this into like a space question. Okay, there we go. Now we're getting somewhere. So I don't want to just keep throwing a bunch of digits at the students, but to describe it would probably be pretty alright. Where's the joke in this, though? And I do want to know if I can actually put in different things in it. Maybe that's the way. The question words itself like it assumes planar geometry, but it actually involves spherical geometry to properly solve. It's like finding the volume of the Earth. Don't give them an equation, just like solve it. You need to calculate pi before we find out how big the Earth is. No, but pi is like very common. People know about it a lot. So, I feel like this might not be a good one. So we might just finish this one out as it exists as a question kind of joke. But we're gonna have to probably making pi funny is not too easy. So I thought, well, we could get close. We can say the circumference around the Earth is about something many miles. And we say miles because I'm American. Then that's what units we use. Otherwise it becomes a physics problem. And then we can find out the radius. The radius of the Earth is actually something many units away. So we can make something work. But yeah, here's what we can do. So we'll calculate we have several options. The volume of the Earth, how big the Earth is, or calculating pi from it. Okay, I have a good idea. So a similar idea, except and this will just be a rephrasing of this current question. But we'll do another question, another page, where when you have to divide out as much as possible. But I'm just coming up with stuff. Let me go back to like what's on track. Okay. I want questions that you can't really do. Or questions that are foolish to even attempt. I don't want them to be too hard. But I want them to be kind of, if you know, you know, kind of thing. So we'll run this one out. If the Earth is, which by the way, how big is the Earth? How big is the diameter of the Earth? in miles. In American. The diameter is about... What? 7,926 miles? That doesn't seem right. What? This is a website, a very legitimate source. How large is the Earth? Earth's circumference, the distance all the way around the equator, is 24,901 miles. So that's the circumference. Its diameter, distance from side to side, is about 7... Okay, give me a different number this time. 7,926 miles. That's actually not that long. Do you guys have like a car that has more mileage than that? Think about that. So, like my car right now, it has about, I want to say about like 40,000 miles, which means that I've driven through the Earth about 3 times. 4 times. Hold on. 7 times what? Oh, it's basically 8. 8 times what is close to 40. About 5 times. That's actually a completely different when you contextualize it like that. So, going through the Earth, it's only 8,000 miles. So, I mean, if you phrase it like that, driving through the Earth. And then, of course, the circumference is about this much, which means that my car has driven about an Earth and a half. Well, that's interesting. That's weird. So, wait, okay. If you guys have a mileage, if you guys have a car, what's the mileage on it? Take your mileage and divide it by the circumference of the Earth. You've driven around the Earth probably more than once. That's interesting. And they say science communication doesn't work. Fascinating. Well, hey, the more you know, right? Okay, we'll take these numbers. So the Earth is about this many miles. Which actually, this actually is probably becoming like a legitimate worksheet then, isn't it? Damn it. I wasn't trying to go for legit. I was trying to go for funny. And we're accidentally learning on stream, aren't we? Cool. It works. It works. Okay. The circumference is that many miles. Make this a little longer. The diameter. The diameter again is about 7926 miles. We're accidentally learning on stream. Oops. Who learns math? It's more of a space fact. Okay. We can calculate pi by dividing the circumference by the diameter. You realize you missed the chance to write pi equals 2 in LaTeX? Yeah, hold on, and let me fix the stream elements overlay again. Because for some reason it wasn't working during one of the other streams. So, gaming chats. Type it out again. Hold on. Type it out again. There we go, try it again. No, it was just, it was not displaying some names. So, like, if it works again, it should work. Okay, now that's the new one. So go ahead and try it again. Yeah, so like some people weren't getting displayed, but we could still do huge PP, right? Yep, okay. Good. So let's thin this out a bit. Thin this out a bit. Pi equals 2. It's not, but let's say it is. Okay. So I don't think this is a convenient number. But let's actually divide that out. So 24,901 divided by 7926. 3.14168559 and so on. Damn it, I'm actually just doing a math problem. I didn't want it to be an actual thing, but you know what? Let's just get through this one and we'll do that. And then I'll have a big old underline that says, you know, fill it in right here. Oops. So, C divided by D is equal to what? Hi, Nova. Hi, Nova. He's my artist. He made me. What are you doing, Nova? I'm gonna shut you out. Nova made me. He was my artist. He made all the assets. Pretty cool. Pretty cool dude. Wait, what? Wait, what, Adapi? Yippee! Yeah, we're going for the dry humor right now. This is I think the diameter is the diameter of the sphere. Well, yeah. The diameter from here to here, the Earth sphere. Yeah, no, that's right. Because it wouldn't matter too much if we're talking about surface area, divided by the diameter is still just a one dimensional, so you wouldn't get too confused about that. Also, there's an ad coming up, so let's enjoy that. How you doing? You know what I'm doing here. You know why I'm doing what I'm doing here? What am I doing here? I know, you're here to collect. I was thinking about if you actually measured the length of the circle, measured in planet Earth as if Earth was the only thing in existence. Oh yeah, no, it's I see what you're trying to go for. Measured in planet Earths. Yeah, I see what you're saying. It's kind of funny though. It's good. So I want the fraction. So I can't type this out in LaTeX, I think. So I'm going to have to do something elaborate. What value you get? With what value you don't get 2, I guess. Yeah, you shouldn't get 2. I'm not sure how you got 2, but I'm more impressed by that. Okay. One-minute ad. Good. They're not too long. I didn't put them on for too long. So C over D. What? What? Welcome back. I'm trying to make this thing look legit. You know, I could be doing anything else. And I chose to do this. You believe that? If you want to define the radius as the distance from the North Pole to the equator, on Earth the distance is exactly 1/4 of the Earth's total circumference. Oh, is that actually true? I don't know anything about like Earth stuff. I don't really much care for it. I don't know the answer. The numbers are wrong because the Earth is flat. That's right. That's right. It is in fact not even round. It is flat. That's why it's two-dimensional, like this picture right here. Earth isn't even real. Middle Earth is coming out soon. And make sure that you watch the pigeons. The pigeons are charging on the power lines. They are not real. The equator cuts the Earth in half. Of course. I see what you're going for. The great circle. Big circle. Okay. And also, hi Tyler. How's it going? I accidentally made a legit question, and I didn't want to. I didn't want to do it. We have another one. Take a look at what we have so far. We have wait, were you here earlier? We got this question, where it's a cutout question, but the joke is that when you cut out the shapes, due to the triangle inequality, you cannot make a triangle with these 3 shapes. So it is dumb. It is really dumb. This one is like a legit thing, so I didn't mean for it to, but it's funny because I'm accidentally learning something, so that's kind of bad. I wanted them to be jokes. Okay, here's what we'll do next. Next question, it'll be you're making it too legit. I know. How do I not? I should have prepped this a little better. So here's what we'll do. Another question. We're gonna do a maze. It's gonna be a maze question. You know, a maze activity. The joke though is that we're gonna be going through a fractal. So the joke is gonna be, oh, help so and so get through the maze, and the maze looks like, which fractal do you guys want? Do you guys want a snowflake? Like one of the generative one of the line ones. Would you want the snowflake? Would you want the square one? Would you want the Sierpinski's triangle? Although that really isn't a maze. The best one I can think of is probably like the snowflake. Snowflake, and then you have to like run through the entire thing. Sierpinski's would be pretty funny. Or we could do Conway's fractal. I think it's Conway. Or Conrad. Conrad's Fractal. No, it's Conway. Is it not Conway? So, Sierpinski triangle. If I can spell for once. Here's what we got. Hilbert curve looks like a maze. Okay, cool. Because here's the fractal I'm going for. I was going for Sierpinski, but there's no entrance to do it, so we can't do that. So you're saying Hilbert curve? Hilbert curve fractal. Let's just look at that. So what's so funny about this? Oh. Oh, okay. That's a good one. That's a good one. Okay, that'd be good. That'd be good. Okay, so how many iterations are we going for? We can look for a Hilbert curve for a few iterations. I could say like maybe 5 or 6. And the way I'm gonna have to draw it out, the lines themselves are the paths. So it's only one way through. So, but you're gonna have to go through the entire perimeter of it all. So I would need to like invert the image so that it looks like the white space here is the path, or the other way around. You know what I mean? Help Hilbert get through the maze. That'd be good. Okay, that's our next one. So I'm looking for a good Hilbert curve. I need a high resolution one. So let me go over. Yeah, you guys can't see this, but it's okay. I'm looking for all sizes. I want large. And there's a 3D version of it too. It's a pretty cool algorithm, actually. Pretty cool. So what is this in? Hilbert space filling curve continuous fractal space filling curve, first described by the German mathematician David Hilbert. I like the hat. Was he a good guy? Let's learn more about him real quick. Mathematician and philosopher of mathematics. Discovered and developed a broad range of fundamental ideas, including invariant theory and calculus of variations, commutative algebra, algebraic number theory, foundations of geometry, spectral theory of operators and its applications in integral equations, mathematical physics, and the foundations of mathematics, particularly proof theory. He did a lot. He adopted and defended George Cantor's set theory and transfinite numbers. In the 1900s, he presented a collection of problems that set a course of mathematical research for the 20th century. That's cool. So he kind of like, he dealt with infinity and stuff. Let's see. Pretty interesting. Those problems are famous. What are some of those problems? Contributions. Solving Gordon's problem. If you solve them, you get rich. Is that 23 problems? Here we go. Hilbert's problems. Some of them include Cantor's problem of the cardinal number of the continuum. So that one is Aleph. I think it was Aleph 2. The power set of Aleph null. Is it within? Is it within Aleph 1 or one of the other ordinals? I forgot what it was. I should know. The compatibility of arithmetical axioms, scissor congruence of polyhedra of equal volumes, set of a straight line as the shortest distance between 2 points, Lee's concept of the continuous group of transformations without the assumption of the differentiability of the functions defining the group. That's a lot of words. Which one's an easy one? Extensions of Kroneker's theorem on abelian fields and to any algebraic realm of rationality. How much do you get? Like 15 bucks? Quadratic forms of any algebraic numerical coefficients. Okay. Those are... Wait, so he developed all these questions? Easy math worksheets. Hello. I don't have the sound alerts, and I still don't have it ready. 𝖈𝖗𝖊𝖎𝖎𝖙𝖘, question for you. We're making a Hilbert curve maze. That wasn't a question. That's just that's a fact. Oh, we got some stuff right now, though. Pretty funny. Let's see. If you wanted to see what we got so far, we got... I made this one earlier today. It's a Fibonacci counting worksheet. So the joke, though, after the first few numbers, you're doing the first 50. And I'm sure you might know, but the numbers do not fit here. And the joke is you can't. Brilliant joke. I know. I like this next one, though. This one's a triangle inequality one. So this one's... it does not fit. Yeah, because, like, the first few... you mean they exceed the acorns? They need to fit inside the acorns, which means either you write them really tiny, or they're gonna overextend into the other numbers. It's really, really funny. The first 50 Fibonacci's are like crazy big. Okay, this one's a triangle inequality one. So the idea is that a student will have to cut these out, and sure enough, when you move them here, oh great. Let me push you back then. Layer, then back. Send forward. You should be on the top layer. Yeah, the joke with this one is that you cannot make it because the two sides don't add up. So that you can't make it a triangle. Hilarious. And then the third one, we accidentally made a real question. Like an actual worksheet. So, oops. So now we're making a Hilbert curve maze. So, actually, are there any images of that? I highly doubt it. Hilbert curve. Nope. So I'm gonna have to import a picture. Or would I resort to AIing? I don't want to use AI. But if it lets me use it for free... Oh, yeah, I can upload stuff then. Okay, let's see. We gotta find a convincing Hilbert curve. So, it's okay. At least one of the questions has to be solvable for a worksheet to have credibility. Yeah, so it looks good for the first half, so I might have to make it number 1. Number 2 is the actual doable Fibonacci one. Number 3 is impossible. We'll make that the triangle inequality. And then number 4, yeah. We'll make an impossible maze. So I found some images over here. I just might need to post-process it so that they end up looking good enough. So go back some. Oh yeah, and then Adapy was trying to make trying to push the spherical geometry. Which, by the way, bummer that I can't do the trivia night because timing wise. But it's okay because I need to make money, so that's like at my actual job time. So here I can... Are these images? Okay, I need an actual... I don't want the GIF. I want the Hilbert space. Here's a okay one. Now I want one more iteration. Here's what I found on the internet. So here's what I can do. I can take one of these pictures, I can post-process it, and then upscale it. Or I can manually trace the entire thing. Because I also want them to be thick enough so that it actually looks like it's a maze that you're going through. Oh, somebody made molds of it. Like, sand molds. Kind of funny. Are there any other space optimizing fractals like that too? Or algorithms that happen to do that? I'll use this one. I see one right here. I'll do this. Okay, so we're gonna use this image, upload this, and you guys don't get to see any of my files. This song is driving me crazy. I had another set of songs I was gonna go all goo goo gaga, you know, because we're learning in class and stuff, but it's like an 8-hour long playlist, and I was not about to. I don't think it's still ready yet. And I am getting hungry, surprisingly. Started at 6, so that's good time. I'll probably try to do 2 more questions, and then I might actually take a quick break. Oh, that's a paper on that. Ooh, I'll have to look at that later. That's cool. Another path filling curve. Space filling tree. Oh, that's cool. How does this work? Space filling trees is also defined as a variety of other shapes and volumes. Below is a subdivision scheme used to define a space filling for a triangular region. At each region, additional branches are added to the existing trees, connecting the center of each triangle to the centers of the 4 subtriangles. Okay, so it's basically just iterating the same path over and over on itself. That's kind of good. Yeah. There is a feature. There's like an add-on in Blender where you get to basically iterate many meshes on top of like the end of a vertex. So all those vertices end up having the same thing. So it basically makes a fractal. And you can use any kind of shape you want on it, which is good. Oh, and I actually want to show something cool real quick. I made time to actually do something I've been wanting to do for a minute. And I learned how to do the path finding, or path, how do I phrase this? Path tracing. So, it's not the most intense or craziest thing, and there's actually some quirks behind the scenes on this one, but this will be good for, like, let's say orbits or circles, or tracing moving objects, so, or paths and things. So we can do all sorts of like visualizations with, let's say, kinematics, waves. We can do basically anything that we need to keep track of, like its space time, parameterizations, 3D calculus, things like that. Now the thing is, I need to actually make it. I gotta refine it a bit, but I like how this one looked, and then I actually liked how this one looked too. I've been meaning to do this one forever, and I had no idea how to do it. So this one's another one that looks good. So it looks like it's just the curve, but actually, there's some tricks to make this one work, but it's nice. So there'll be more things like that probably in the future if I need a visual for things when we get into our more intense like theory talks and stuff. I have yet to do anything too serious. Well, the next one we're gonna do a talk in the golden ratio this coming I want to say Saturday or Sunday, one of those days. Sunday, right? So yeah, pretty cool. So we'll I always like making animations, but making them tie in would be kind of hard. At some point I do want to make a fully edited video for a discussion for YouTube. So it'll be like I hope like a 10-minute video or so. So here's what we'll do. This one right here. Oopsies. I only need one. And can I replace the background? Oh, this is the background. So what would the entrance be to one of these guys? Right over here? Technically, no. So let me... So I'm going to start this one upside down. And then I'm going to make it big. This looks serviceable. So it'll start from, let's say, I want it to be over here, will be the entrance. And is it even possible to get through the end? No. No. But hey, it's a fake it till you make it kind of thing. Pen! How's it going, Pen? How's it going? Did you beat the game? Did you become a squid again? I'm trying to make my math pun things, the worksheets at work. So we got another one that's pretty funny right here. So, and I guess anybody, some of you guys know who I am. Hello, I'm 𝖈𝖊𝖉𝖎𝖙𝖚. I'm a math VTuber. I like covering dumb math topics and making things fun. You're doing Squid Games. Oh, JEE contest questions, Squid Games in 1 hour. Like, legit. That's cool. You try to tell us 0 isn't a natural number? I don't know how to tell you this. Does 0 belong in the naturals? I wouldn't. I don't want to break hearts here. But yeah, hello guys. Let's see. I can cover some of the questions that I've got so far. These are basically math gag worksheets. So you can open it here and then here and there, and you're making an actual solvable maze if you want to. I think it'll be fine. I think it's just for the gag for now. I got like 2 more questions that I probably want to shoot. Okay, so here, the first question, the first worksheet. We're counting our Fibonacci numbers. So the joke here, we're gonna be filling in the first 50 spaces because this is like a counting worksheet. So you would fill in the number with the actual number that there is. So 1, 2, 3, 4, 5. I'm repurposing this to be count your Fibonacci's. So 2, 3, the next number would here. What's 2 plus 3, guys? What could it possibly be right here? So the joke is basically just keep doing it. Square root of 25. You bastard. Yes. Okay. Yes. Sure. So 5, 8, then 13, 21, 34, but the numbers keep blowing up. So the joke there is going to be there's not enough space to even fill them in. So that's good. Lucas numbers worksheet. I'll have to look into that. This one is a triangle inequality cutout question. So you start out with a shape. You're trying to make sure the ends touch, right? So actually, let me make this a little bit smaller because I don't like how long it is. Okay, so the joke here is, according to the triangle inequality, the sum of the two smaller sides needs to be bigger than the bigger side. Well, look what happens here. Wait, what? What am I doing? Are you telling me there's no way I can make a triangle? Womp womp. That's hilarious, in my opinion. So the joke is that you can't. So that's good. Next question. This was an actual, like, a legitimate question. Like, this was actually real, and I kind of baited myself into doing an actual, like, worksheet problem. So this just tells you the circumference of the Earth and the diameter of the Earth, and we can just calculate pi by taking the ratio. Oops, an actual real problem. So I'll probably put this one on the first one so people can think it's like legit. Then we're doing a Hilbert curve maze question. You're gonna start from here and then you're gonna go to the end. And the joke is that you can't, because it's a fractal. And this one also has, by generation, it's different. You picking up what I'm putting down? Are you adding what I'm subtracting? Something like that. Yeah, it's all done. It's I have like a few more gags I can probably think of, unless you guys can think of one for me, because I'm kind of going off of like sheer spirit right now. Let me make this pretty big. So this is Hilbert curve maze. No exclamation point. Classic division by 0 proof resulting in 1 equals 0. I could do that. This will just be, that could be like a solve the equation. You start here. Did the algebra complete the final step? That'd be good. Now we need a big red arrow pointing where we start. I want it actually on the bottom over here. So like in an inlet right here. I do need 1 equals 0 question. Or would I have to make one myself? That'd be good. You can't divide by 0. Yes, you can. Just cancel them out. I need a big Clifford the big red arrow going on right this. Calculate the last digit of pi. That was the gag. That was the idea I was going for this one. The joke is like get the most accurate answer, and the joke is that you can't. But then I found out you can't just take the ratio because one of those numbers has to be irrational. Just by the nature of the question. So, damn it. I can't just do that. So I thought. But we could get something similar. So for now, it's just an actual solve it question, which is fine. This one, make it a bit bigger. I want a picture of Hilbert's. I don't know where I can find a picture of Hilbert's. Just chilling. Reverse the digits of E. Good joke. Maybe we can do something about limits. I want like a series question. So I actually thought of like, we could do like the Achilles. Not Achilles. What's that one with the paradox? Where you're running and racing against. Was it an actual turtle? you know, but to have to get there, you have to be halfway there, and to get there, Zeno's paradox. That's what it is. He was the guy who was like, if to actually get there, you have to be halfway there, and then you still have to cover another half, and then another half, and then another half, and then he ends up like, you know, but you can't do that forever. But nowadays we have this thing called limits. So yes, you can do it because it doesn't diverge. I have another question about not that one, but let's say like your starting point can't even start. The joke could be like, what's that one like sine noise fractal? You know what I'm talking about, where it's like the sine wave, it's a sine and cosine, and just like the more and more you look close to it, the more it's you can't really get to it. Anyways, there's a few ideas that I have. There's all sorts of funny things. The Weierstrass function, yes. See, it goes to show I know the idea of it, but I really don't remember the name of it. Parabola is easier in case you missed it. Well. Oh, okay, wait. I have one. I do have one. You have a Desmos graph ready to go? If you happen to be able to send it, if it sends through the chat, you can go ahead and send it in. I have another one. Okay, a riddle. So it would be a logical riddle. So you guys, who's taken discrete math before? You probably have done stuff with logic, logical operators, and so you had conditional truths. So if it's Wednesday, Jackson gets ice cream. It's Tuesday, and Amanda. If it's Tuesday, then Amanda and Jackson buy 2 ice creams, or something stupid like that. Russell's paradox. Don't solve it. Tell them to identify the elements of the set for all sets. Logic could be fun. I remember doing some practice with it. Let's see this Desmos one. Hope it's not a funny thing. Yeah. Well, this is interesting. Wow. Aren't fractals cool, guys? Okay, so we can probably put this in somewhere. I'm not sure how to make this one work, but how would we phrase something like this to make it funny? So the thing would be like, help Hilbert get across the maze. Help Hilbert get across the maze. Let's see. And then it's gonna be a little picture of a little Hilbert guy. If you haven't seen this one before, the Weierstrass, it's pretty neat. So it's non-differentiable at every point. Is that right? So it's a non-differentiable function because of the nature of the fractal. You can't actually find the limits of each of these guys. So every time you zoom in, you keep finding more noise, and it never smooths out. Continuous on R, no derivative anywhere. Okay, we can definitely phrase it like that. We could say, calculate the derivative at some point. Definitely remember for answering exam questions. Yeah. Okay, so I need a picture of an old person. Old man. Cartoon with mustache. These aren't quite what I want. I want a cartoon. Old man. Don't need a real one. Should I just put like his actual picture in? It would be so like tacky to just do it. You have a cool effect by letting the B parameter play on the graph. Wait, what? Ooh. It wiggles. So B right here is your phase length. Your phase thingy. Oh wait, that actually is for complexity? So if I zoom in here, then I actually do get a smoother curve. I thought it was for... Tacking and worksheet go hand in hand. Yeah, we got the budget of like 2 cents, so I guess it's fine. You're right. Pretty cool. And what does K do? Whee! K is just your limit. A. Oh, that's a noisy boy. Oh, that's an angry function. Oh. That's an angry function. I like it. Nice. Yeah, that's the amplitude. Yeah, it's an angry parameter. Urgh. Let's crank it up. Let's see what it does. Cool. So, pen. Let's see. A colony of bacteria replicate in an odd way. If there are an even number of bacteria, half of them will randomly die. If there are an odd number of bacteria, are you doing the Collatz conjecture? That's good. How many bacteria should we start with in order to maximize the number of the colony? That's a good one. That's a good one. Okay, we can add that. Send that to the kids. Okay, let me get this Hilbert picture real quick, and then we'll move on with that. I know some stuff. I'm not good at some stuff, but I know some stuff. I know a friend of a friend, right? It's not infinite. It terminates. And the conjecture is, let's cover the. Hold on, we're in Wikipedia. The Collatz conjecture. Close enough. So the Collatz conjecture. Huh? Buddy. 3x plus 1. Yes. So it goes like this. For any function, for any integer that you plug in, if it's even, you cut it in half. If it's odd, you triple it, add 1. But people usually divide it by 2 because that's the immediate next step anyway. So all of the terms end up cyclic in, like, think of like 1, 2, 4 kind of like group or something. So it's a math problem that does not have a proof, and the reason why it always terminates so far is not known. I found this out during a computer science lecture, actually, where my professor was talking about, and then imagine you had an alien species that did not use carbon, and they used, let's say, boron instead. And by the infinite complexities of the universe, if we were to arrange all the atoms into a supercomputer, we will not be able to have enough time to solve a problem of complexity something something. Basically, it was rambling, but he brought it up, and I thought it was kind of cool. So fascinating stuff. I actually liked him. He was a very fun professor for all the wrong reasons. So yeah, this is a good question. So and there's other versions of this as far as I understand. But yeah, this was like a time waster question too, because I think mathematicians, like during like Soviet times, during the Cold War, were working on this problem for whatever reason, and they were told to stop working on it because if they were working on it too much, then they were wasting their time on a meaningless, fundamentally useless question. So pretty cool. Mathematics may not be ready for such problems. Correct. So let me go ahead and upload Hilbert to this Hilbert space. Let's see. So I guess we can do another one that is Does Hilbert have like a catchphrase or something? The answer is left. The answer to this question is left as an exercise for the reader. Brilliant. I did like this website. You showed me this website a minute ago. Let's see. The proof is trivial. It's a website where every time you reload it, it gives you a bullshit explanation for why the proof is trivial. So, a proof is trivial. Just view the problem as a simplicial manifold whose elements are countable bijections. Of course. Don't you know? Even grade schoolers can do this. Now, this one. The proof is trivial. Just biject a non-degenerate complexity class of elements are prime equivalence relations. Whose elements are prime equivalence relations. It's trivial. I want to write a book one day. Yeah, it's literally called theproofistrivial.com. Pretty good. Yes, okay. Thank you so much for sharing that, because I actually do like it. Let me save it in my bookmarks too. Good. Great website. Great website if you want to just share it with some people. And I was saying, if I wanted to write a book, one day I'm gonna have an explanation for a proof, and my proof is gonna be I made it the fuck up. But that's not very professional, so an equivalent to that. My source is that I made it the fuck up. I love that one. So the joke is that you're supposed to start from here, and you're trying to get out which side? Bottom here? End. Spurious correlations? Correlations. It's not a cautious. Thousands of charts, real data showing actual correlations between ridiculous things. Conspiracy time. Guys, have you ever seen a baby pigeon before? Guys, they're not real. They're made by the government. They charge on the power lines. Excellent. Alright, popularity of the not sure if meme correlates with the number of air traffic controls in Montana. Interesting. That must be true. So the memes are affecting air in Montana. Of course. How? It's trivial. Think about it. Just view it as a problem of greedy poset whose elements are open algebras. Duh. You ask the reader to show two different diagrams of the same knots, or actually diagrams of the same knots. Another page. That'd be good. I just happen to not know if the two knots are in fact the same knots. And I guess by eye, not many people would, but that's a part of my that's part of my model actually. Let me show that off real quick. So let me zoom out a bit. Look at my knots. That's how I tie my knots. This is a tenfold knottiness image that I found and use that as my shoelaces, because I thought it'd be funny. Let's see, you're falling for my trap card. Yeah, you triggered my trap card. Okay, let's see. The number of websites on the internet correlates to the total wind power generated globally. Well, functionally, that is kind of true, isn't it? The use for internet and electricity does, in fact, correlate with the renewable, need for generation of electricity, right? Am I not wrong about that? It's kind of, it's not for the right reasons, but it would be true, right? Duh. Okay, here's a good one. Popularity of the first name Tiffany correlates with air pollution in Los Angeles. So, Tiffany is responsible for air pollution in LA. I did not know that. Well, who was the last Tiffany I know? I don't think I know many Tiffany's. Stop calling people Tiffany! Makes sense if you're confounding variables. Yeah, it's just ridiculous. This is great. I'm also going to save this. Save. Google searches for my cat scratched me correlates with the Coca-Cola company's stock price, KO. So cat scratching you correlates with Coca-Cola stock price? I believe this. So, what's it called? You gotta check the p-value. I did this bit earlier, but you want a small p-value. You don't want a small p-value. You want a big p-value, because big pp is good, right? Hold on. Do the thing. Huge pp. Yeah. Is it not working? Gotta capitalize huge. Fat pp. Close enough. CGP Gray had a video on the origin of Tiffany. I gotta learn about these things. This is ridiculous. How good number file YouTube video titles are correlates with the number of actuaries in Utah. Huh? You can't just cite the whole thing as huge. Capital letters. You capitalize the H. Just the H. Case sensitive. Let's see. Popularity of the first name Jordan correlates with the robberies in South Carolina. Really? There you go, Pen. You got a big PP. Good job. Huge PP. Oh, here's a good one. Okay. Bachelor's degrees awarded in liberal arts correlates with the number of pediatricians in Massachusetts. And it's declined? For some reason, liberal arts need you to be a pediatrician? Oh, I feel bad for Massachusetts. Womp womp. Okay, I can spend all day on this one. Let's get back on track with it. Pretty good stuff. Yes, you guys are typing huge stuff things in the chat. Pretty cool feature, huh? Did you ever get that thing working in your chat, by the way? Small. Just do subscript. And here. You haven't tried it yet? Do it. You won't. Here we go. Some good stuff right here. Okay. This is good. This is good. And this needs to be green, because green means go. Okay, we got two choices. We got puke green and snot green. Which one do you want? As a department chair, I don't have a lot of extra time at the moment. Oh wait, you're responsible? I don't think I've explained my actual occupation very well. I'm trying to go back to school. I think the arrow needs to be let out from a space that isn't space with visibility shallow. Isn't this one though? Oh, okay, yeah. Not here. So not there. So maybe like right here. 25 faculty members. Look at you. Having a big boy job with big boy responsibilities. I thought we were doing something else. Yeah, huge responsibilities. I thought we were just in for the meme. Oops. I think I'm in a different ballpark then. But that's good though. That's cool. That means you're surrounded by people. That's good. Okay, so this is good because the direct straight path does not work. Neko, how's it going? Okay, snot green or puke green? Which one do you want? Snot green or puke green? Hello, Raiders. Come on in. My name is alephmuvt. I am a math Fractal Vtuber. I like covering math stuff, mostly for the memes, but I'm also studying to go back to school. So hello. You want the lighter green? Sure. We are doing a bunch of gag worksheets for fun. So we got several different styles of math worksheets, and the joke is just that if you know that it's an impossible thing to do, or there's a trick to it. So what were you guys doing? America, yeah. Hello. Hello. What a chill day. What a fun day. Happy April Fool's Day, guys. Apparently they went to the moon. They're gonna go to the moon to make sure that the moon is still there, so that's cool. They're gonna make sure that we didn't lose it. That's why we sent them to space. So yeah, we were doing some like gag April Fool's style questions. So this one, the joke is that you can't solve it because of the fractal, and technically by nature of this fractal generation, it's not even possible to even like go through it. But it's funny to imagine it. If it was inverted, if the blue line was in fact a path, like much thicker and you could see it better, that would be good. Because you end up just covering the entire perimeter of the thing. But no. Okay, let's do another one. The Hilbert Maze question is done. What's the next one? We could do the Firestrass. Fractal's funny. Yeah, there's a bunch of really good ones. Let's see. So the Fractal one is made by this guy, David Hilbert, who apparently did a lot of crazy stuff, known for the basis theorems, the null Stalin sets, axioms, the problems, the programs, lots of things. Hilbert spaces. He's kind of a smart dude. A Monty Hall question would be good. With enough dilution, it seems like a bunch of Among Us. Among Us? Among Us. You need to vent. Same as the 2 envelope problem. I'm missing the context. Known as the exchange paradox. Okay, is this it? As a paradox in probability theory, it is of special interest in decision theory and for Bayesian interpretation of probability theory. It is a variant of an older problem known as the necktie paradox. The problem is typically introduced by formulating a hypothetical challenge, like the following example. I'm gonna read this out anyway. Imagine you are given 2 identical envelopes, each containing money. One contains twice as much as the other. You may pick one envelope and keep the money it contains. Having chosen an envelope at will, but before inspecting it, you are given the chance to switch envelopes. Should you switch? And I need to drink water, you're right. My bladder's quite full. Make multiple choice for both options are correct. Oh, okay. So let's do something like, okay, if we want a Monty Hall, let me show what Monty Hall is. Monty Hall problem. So basically, that's the one where you get 3 options, and then you pick one, and if then the other one is shown to you to not be the correct one. Should you change? And the answer is, even though you picked one, you should always change it. So, but how do we make that as a joke? The picture kind of shows it well. There were 3 vents. Same for the 2 envelopes, you always swap. But the probability space is the same. Isn't it? Okay, let's try to do a Monty Hall. Let's do that. So add text. Come back up here. Pop. 2 envelope is where one money has... Yeah, one has more than the other. Yeah. So let's start with Monty Hall problem. So yeah, we're just trying to like disguise a bunch of like math things into like a gag April Fool's thing. If I run out of ideas, then I'll probably start wrapping things up eventually. What did you guys do today? Anything fun? Did anybody go see the Mario movie? I wanted to go see it, but my brother was like, I already got tickets and screw you. And I was like, but brother, I had work. He left me. You did not see it? You should. I'm gonna go see it, not because it's particularly my favorite, like I'm that hyped about it, but because it's something to do. And I do like Mario, so I see no reason why not to look at it. This one, outline. So do 32. Okay. We do a Monty Hall problem. What's the thing that we want to win? Behind one of these curtains is the solution to a multi-million-dollar math question. And the other, it is your 10-year expiring. No, something funny. What's in the other curtain? Do you change? Do you change your career paths? No. Something dumb. Child-friendly setups to make it trivial. Behind you see a... Yeah, okay. Yeah. That's right. Monty Hall problem. So then I'm gonna have the question below it. So let's make 3 different curtains. So question then. There's always 2 bad things when you choose, right? There's always 2 bad things from the curtains. And 1 good thing you actually want to win, right? Or, you know, less opportune things. So, what would it be? Well, do you want the ice cream, Jimmy? When do kids have a choice? When do the children actually want to decide? Dessert options? Yeah, we could do desserts. So here's what we'll do. We'll do a platter. Ice cream or salad. Ew. So we'll do a platter, silver platter. So that it's covered up. Broccoli, specifically for Americans. Yep. We don't want icky broccoli. We want yummy hamburgers. Wait, you're not American? That's what we want. That's what we want. Okay. Okay, good. Now, your mom tells you that this platter has broccoli. Do you swap your platter? Yes. Okay, that's a good one. Your mum, British spelling. Or Canadian? Non-American, that's what I say. That'd be a nasty parent. Behind one of these is British ex-colony. Christmas Island. I don't know. Who still says mum though? Hold on, I'm thinking this out. Belize? Belize doesn't say that. I don't think they do. Now it's just a guessing game. Excuse me. It was an ex-colony though. I don't know. I'm not from Oceania. Oh, Saturday. Oh, shoot. So you're Irelandish. That's cool. I actually really want to go there. I really want to visit. I'm not sure which one, north or south, but either one. One of them's cool. Oh. Ex-colony. She's British. Yeah, I know she is. And she's living in Ireland right now. Okay, Monty Hall. Let's get this together. Yeah, if you phrase it like that. Yeah, take your time. Okay. Your mom decides you pick a tray. To have for dinner. And then I don't know, A, B, and C. A choice. I want one where it's like, it's futile. Ads today, pretty low quality. That's why I don't have too many on. Ah! Sparkly Anarchy, what's up? Hello. Hello. We're doing math. Happy April Fool's Day. Caught us in the middle of an ad break too. Hello, 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 hello. For those coming in, my name is alephmuvt. I'm a math VTuber. I like covering math topics, math problems, and today we're doing a gag, joke, April Fool's math worksheets. So today we are designing problems that a kid would do, but some of the problems are jokes. I can show some of the ones that I have already because they're dumb. So like this one, right? This is like a counting worksheet, but the joke with this one is your Fibonacci numbers, right? So we want the first 50 spaces to be our Fibonacci numbers. So we start with 2, then 3, and then we have to add the last 2 together to get the next one. So the next one is 2 plus 3, which gets us 5. After that, 5 plus 3, 8. So the joke, though, once we start getting bigger and bigger numbers, at some point, like by the end of this row, so the 10th one, the 10th Fibonacci number is actually like crazy big. So the joke is that there's not enough space for them to actually fill it in. And I find that incredibly hilarious. So yeah, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 144. And it quickly starts blowing up. So 144, 233, 37, all these ones, 6,765 on the 20th one. So going back up here, they have to fill that in this one. And then the 50th one is just crazy big. So they don't have enough space to do it. Over here, we have a triangle question. Here's, they have to calculate pi. They have to do a maze they can't do. And then now we have Monty Hall. Lots of stuff. What's another one? What's another good one? Which of these numbers could you count with just your fingers? That's a good one. Multiple choice. Okay. That's a good one. I'll do that. I wonder. Yeah, I don't feel obligated to like stick around. I'm just kind of doing this for fun. We do actual like math stuff other times. All must be, but all must be greater than 10 and all correct. That's good. That's good. Okay, that's a good one. So standard 0 to 10 is obvious. 0 to 99 is doable. Do you think so? So, go further with binary? I suppose you could. I would not know. You can technically count any number up to with your fingers, can't you? So, okay, let me fix this phrasing. Multi-hole problem, pick a tray. The way I count on my fingers lets me go to 99. How many fingers do you have, Pinboo? Well, you play like every instrument ever, so I suppose you have enough fingers to play anything, don't you? Yeah. Thumb is 5. Oh, like actual counting methods. Okay. Digits are ones. Yeah. Okay. Let's get back on track. So how do I phrase this? Pick a tray to have dinner. And then what? I have another slide. Wikipedia has it under 𝖘𝖔𝖈𝖎𝖎𝖙𝖘. TLDR, use your fingers like an abacus. I've been meaning to do that. So, I have an actual abacus. I bought one. Maybe I can share that real quick, the noise at least. So I bought an actual abacus because I wanted to do some actual like counting and do the mental math tricks, but I could not practice without having one. And now I am barely good enough to do it. I still need to practice my multiplication and my division and subtraction. Basically any operation I need to practice on my abacus. But I learned that it exists and it's kind of cool because people can do mental math pretty fast. Yeah, you've been wanting to do an abacus stream for some time. Would you want to join? Because we could definitely arrange something. I'm trying to get Z on board because she's doing like the whole cuneiform Mesopotamia nonsense. So that'd be cool if we just do like a abacus thing. You've done abacus before? Yeah, we'll plan. We'll think of it. We'll think of the idea. That'd be fun. Okay, Monty Hall. So here's what we got. We say here, yours was forced. You had to learn. You need to know how to. You need to make sure that you know how to do it the hard way. Probably learned. Yeah, culture. Whoops. Okay. Okay. So what do I say here? Pick a tray to have for dinner. One tray has a yummy dessert. The other has icky broccoli. Ew. Well, you don't like broccoli. Choose wisely. Okay. Make your own choose your adventure style problem, maybe. Okay, so this is like a two-part then. Because technically this would be a slide for like a PowerPoint. I kind of want these ones to be by themselves, but this will work out for the format. So we want to duplicate this, and now we reveal which one. I don't want them to actually pick one, so I have to phrase like, what could it possibly be? We want broccoli or dessert. Broccoli. Okay. I went to my music. Oh, my thing got unplugged. Okay. Your mom shows you one of the a platter you did not pick. It had icky broccoli. Do you want to switch in case you switch your option? I know, it's like, how do I phrase it without them, like, asking to swap in second makes more sense. Forcing them to choose platter A is the first slide. Oh, I see what you're saying. So let me find the letters. I'm gonna do. Okay, do over here. So A, B, and C. Yeah. Peak geek. Okay. The yummy dessert. Okay, yes. Icky broccoli. You choose. Platter B. Platter A. So many exclamation points. That's just how I talk. It's so annoying. Okay. Your mum reveals platter B or C has icky broccoli. Do you choose a different platter? I think it has to be the others or the other two. It makes sense. Oh, yeah. The other two have grammar. Icky broccoli. So we got A, B, and C. Just choose B or C. Oh, because the first one is the choice, right? You just share it everywhere. I hope you do. Okay. You don't know what's an A. So yeah, it's gotta be. Let's say choice B then. Okay. Your mom chose that platter B had broccoli. Do you still want to change? Hold on. To swap. Yeah, that's good. Swap for platter C. Yes, I do. Yes, I do. Yes, I do. Okay. Now that this is done, what would the payoff be? Do I need another slide for this? Which is the better option? Or the better option? Maybe I can paste it like that. I don't need that. We know the answer, not the kids. There should be like a, if there is like a solution sheet, that would be funny, but we don't. Okay, that's done. I do want to do, let's do one more and call it a day. I probably want to go eat. I must consume calories. And we can end it off on a raid on somebody. We can bully somebody. Let's see. But I do want one last idea. So we got Monty Hall. We got a maze. What's another like children's level like activity? You gotta count your numbers. I'm thinking of like dine in kids menu kind of like activities. Share your worksheet and make them do it. I could. I have the means to oh, coloring question. Oh, I know the perfect one. Yes. Okay, we could do the four color problem. We can do the four color tiling thingy majigger. Yes. Color this map with only 3 colors. No colors next to each other. Yeah. Okay. So here's what I need. I need a oh, maybe I could show this off real quick. The neurons are braining. So let's see. Okay, want to see something cool? So in Blender, there are some noise generating images. So I'm gonna create a full copy, and then all the things I have here, I'll delete them, and all annotations, I will delete them. Okay, take a look. I'm gonna create a plane, and I'm gonna use what's called a Voronoi texture. So create a new Voronoi. That's a good one. This is it. Okay, here's how this thing is gonna look real quick. So once it generates, take a look at that. Now we're gonna have a color ramp. This is disgusting. What's wrong with it? So I can map different colors. So let's say what values split up into extremes? I guess like this then, huh? 0.75. So change these to constant, and I can make these colors different. So 1, 2, 3, 4 different colors, and I can make them gross different random things. So 1, reds, blues, and green, I guess. Primary colors. And magenta. So right here, don't worry, Sparkly, do your thing. I guess this tiling method does not show it very well, but we can change the randomness down. Maybe it's better how it looked before. No, I'm not gonna make it too complex. No, okay, I like the original idea. We're gonna make these black and white. So actually I can do that by just eliminating these, making this one white. Whoa. Less than 10 tiles if possible. Yeah. Oh, if we're doing that then yeah, we'll do size 1. How many tiles do I have here? So 1, 2, 3, 4. So that looks like 8. 1.25. 5 by 5 is 25. Then random. Yeah. Okay. Go back to constant so I can see them just a bit better. I need some of the lighter ones too. My only issue is that some of them blend. Ooh, that's way too much. How did I do it before? There we go. Okay, we'll do something like this. So that was a parameter called 𝖘𝖔𝖈𝖎𝖙𝖘. The scale relative of a Voronoi layer relative to that of a previous layer. This is good. So then I want black and white or keep these colors. Black and white must be it. Sorry, this. Because this automatically tiles it. Clean up the really small partitions. I can change the detail again. Is this acceptable? Too many tiles. And then just to get rid of that last little bit, I'm gonna move over the x-axis. Vector math. And I'm gonna scoot it over. Observe. UV. There, I can shift the entire thing up and down. So here, I like this side, and I'm gonna make it just a little bit taller. There you go. Kids' first coloring book. Excellent. Okay, now what I will do is I will arrange a camera facing down, and I will put that into the coloring thing. So here's how I actually do most of my things. I usually create. Now we actually have to make sure that we can't do a three coloring. I think the way that it's phrased, it's the 4-color problem is by tiling the grid. How do we? So they're unique shapes, right? You know what? Regardless of how well we understand the question, the fact that they have to figure it out is their own, like, hard work. So I suppose we don't necessarily need to know the answer, but it'd be really funny if the answer was like no. Because they couldn't do it. So let's see, and then I can also like up the, not the exposure, no, Yeah, they're basically nodes. There's another way to make this thing look legit, but for now, we will just work with this. Is this acceptable? Why are we doing this? So that I can take the picture. It's basically like a 1024 by 1024. Then I put this into orthographic view, which turns it into plane. And now I just gotta change the size to, let's say like 2 or 3. 2. So now I can take a perfect picture. Is this acceptable? Yes. Can you outline the borders after? Yeah. Heck, I can even do that right now if I want to. So this brim, I can make that, I can make the brim like black. New emission, and it's black. Is this good? So I just got to make it a little bit bigger so that they could see it. Oh, between the spaces. Oh. Oh, shoot. If we want that, then we may as well just do, like, fracture. Wait, no, there is a way. So here's how we could do that. To my knowledge. So suppose that these are random colors. So E's. You can clearly see these are all different colors. Next thing I will do is between the boundaries. There is, I believe, a factor. No, that's another thing. Roughness does something. Detail changes that. Scale, we had this good scale. See, that's the thing. So I have another way to do this. Brick texture. On a brick texture, it does functionally the same thing, except now you get to have a mortar. And you have to have what's called the mortar size. So the mortar tells you how thick the in-betweens are. So I suppose if we put this in as the color of something. Maybe not like this, excuse me. This might be something else. This just looks like graffiti. Hold on. This looks like a really punk city bar area. That's pretty. Oops, that's not what I want. We don't want to build pretty pictures. We want to make ugly ones. So if there's a way for me to plug this into the mortar size, then it would work. But for right now, nah, it's fine. We're just going to have to roll with it. It is what it is. Next thing then, let's just go ahead and take a picture. Go. And we'll do these colors. Actually, to double check, I'm going to make sure these color extremes do work. Let's say I wanted blue. This one needs to be green. And, I don't know, red. And then this one needs to be purple. There's no purple. Yeah. do constant again. Yeah, no, it's just gonna look different. Okay, we're rolling on. We're moving on. I'm gonna use these colors because they work. And then these blues. There. It's a perfectly acceptable thing here. How's that? Going once. Going twice. Sold. Okay. This is perfectly functional. I'm going to save this image, render it out, and that will be our coloration. And then I can create a another version, I suppose. So what is it? Can you color this, or is this... Can you make this one with better colors, or what? How do we make it a coloring activity? It says make it all white and give them 3 colors. Ask them to fill in only 3. Okay, that works. Again, the issue, I can fix the issue right now. I can just manually make it. So, 3 color tiling 1. So to make the tiling work again, I can make them all white, and then I can... I'll do a path. I'll do a polygon. Merge it. And then I'm just going to trace around the entire thing. And then what that does is with a wireframe modifier, yeah, it should be fine. It doesn't matter if they say you... Doesn't matter if they can or can't, like you said. Yeah, it's just a matter of seeing the lines, that's it. And luckily there's enough to work with. It works. It just works. Make it quick, make it quick. Because I'm hungry and I'm starving for some food. This is probably the one question with like the least amount of payoff. Or who's to say? If I was a proper graphic designer, I would be putting in like Einsteins and little chibi images of everything. I mean, hey, at least I know how to do this, which is a skill in enough itself. There we go. So here's what that does. So this plane right here. Okay. So I can create a thick line like that, and then all of these ones are just going to be black. That's right on top. People won't care. People won't notice. Other than these, which I'm annoyed by. But we can fix that by calculating outside. Fixing them up. That worked. This one's. That worked. Try different configurations and you can't find 3 coloring. So this is good. Let's go. Why is it like that? Oh yeah, that's good. Okay, now for the original here, I just got to make it black and white. So, different ramp. Actually, wait, tell you what. Let me take a picture of this one. Again. So do we want the original here? Around here. Oh. Okay, quick fix. Okay, so we have this Picasso right here. Good job. We have another one. So I'm going to save this as a tile 2. And then we need to fill it in with the colors. Okay, next one. This duplicate. Delete all these. Gone, 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 gone. And it's all white. And then let me check something real quick. Wait, what? Ah, shoot. Let me redo those colors. Look, high saturation. That's yummy. Good colors. That's what we wanted. Better than before. So save as. Better than this one. Color 2. Next, I'm gonna hide this one. And I want to retake this one and save this one as color 1. Fill in the 3 colors and find the hidden picture. Yeah. Needs more instructions. We'll figure it out. Last one, this one. Okay, that's it. Hi, ads. Hello. People for some reason stuck out and they wanted to watch me do it. Want to see the math problems we got? Go back over here. We made some gag problems, some joke problems. Now we have our last one. So we had a counting problem with just enough space for you to get through your single and double digits. You're supposed to get through your first 50 Fibonacci numbers, and you're going to put them inside of the acorns. But guess what? The first 50, they blow up. The first few, by the 20, you're already in 6,000. So the joke is that you don't have enough space to do it. Haha. I think it's brilliant. I think it's the stupidest one. Next one, we have to cut out our shapes and make a triangle with glue. But unfortunately, the shapes that we have are not big enough. Because according to the triangle inequality, the 2 smaller sides have to be bigger than the big side. And we don't have that. So when we combine it together, it does not work. Observe. So you take this here. I'm going to take this. Put this over here. And then this one. I'm going to rotate this. And then put that there. Oh no! If only there was a way we could make a triangle. But we can't. Womp womp. And next one, this is like an actual like math question. So like, I didn't mean for it to, but it works. You get the circumference of the Earth, and you get the diameter. And you have to find pi. It's equal to what? It's equal to what? Actually, let me put a black line so I can put it right over here. Round to the nearest digit. It actually gives you the first few digits, but the rest are wrong. Because it's an estimate. Pretty cool. Next one, it's a maze question. So we have Hilbert curve. And the joke is that you can't do this maze because it's a fractal maze. And not only that, but technically we're doing it wrong because the perimeter, we would have to go through the perimeter. And unfortunately, this is not the perimeter. But it looks like it's a convincing problem, but it's not. So everything we have is a dead end, no matter which way we look. And the joke is bad. It's funny. Help Hilbert get across the maze. Next, we did a Monty Hall problem, which is about like picking broccoli or dessert. And last one, we're doing this one. Let me duplicate this slide so that I can just break it down. So we created a 3-color question. So it's going to be a color this in question. So can you color this in with the correct, with 3 colors, none touching each other? You can do anything with 4, but 3, I don't know. And then with that, I think we'll wrap it up for today. Because I'm getting hangry. So good little joke stream for today. We'll be on track with some actual like other problems later. But I whipped this one up in the Blender. So pretty cool. I should have just used like an actual like graphics library to do it. But who cares? You want to send it to people? You're welcome to send it. So I have to phrase this as a 4 3-color question. Hold on. How would I phrase this? 3-color coloring activity with 3 colors. And I want this grid to be a little bit bigger. Change this down a bit more. No title is good. We just have instructions. Instructions just color. I kind of want a border on it. Oh, excuse me. Well, I'm sorry. I'm so sorry. Let's see. Okay. Color this with 3 colors to find a hidden picture. Yeah. Okay. So, should I just do the white out one? So this is... and then the bottom, it'll be the same color, cannot be adjacent. I see. So I'll show like a what not to do then. So this will be a unlock a hidden picture. That's so silly. Okay. It has to be white so they can color it in. Yeah, that's good. So this one here says, color the... Even better that there's no hidden picture. Yeah, duh. Color the picture with only 3 colors. No colors can touch. No. None of the same can touch the next one. Make sure. Okay, color the picture with only 3 colors. That bit makes sense. Then what? Okay, the same color cannot be next to itself. Okay. So I want to make room for this one. No, but that's like 4 colors though. Oh, kind of. There's technically different gradients of it. I don't think that's fine then, huh? Is that functional? Yeah, that's not the 4-color theorem. 4-color theorem says you can do any 4, no matter what kind of tiling method you have. But 3 colors, the joke is that you cannot. So yeah, it is impossible. It's an impossible task. So I think that's about it. So the joke of this one is that you can't do it, and you'd be stupid to do it, to try it. Because take a look, you have 4 intersecting like next to 1. So this one has to be different. This one has to be different. This one has to be different, but we ran out of colors. So if this one was, let's say, blue, actually, you could probably even pull this up in like paint or something. I'll do that later. Anyways, yeah, so basically, yeah, there's technically an exception. Is there? What, with like, doesn't that lead into like fractal spaces and stuff like that? I know what you're doing. I know what you're doing. But do tell. So let's see. With this stuff done, yeah, the triangular K-planar through can be colored with 3. Yeah, and then it has lots of extraordinary things, shapes to do it. Let's see. The Fibonacci's, the acorns. Make it more precise. So I want to make sure that the numbers are in order. So I want to say like row 1, 2, 3, and 4. Last instruction. Let's see. Hint. Add the last 2 numbers from the left of it. Oh. Fill the next 50 acorns. But they'll run out of short ones in 10. Yeah, fill in the next. I kind of put it in order for a reason though, so that they check that this is. They check that this is the, the correct one. Then when they add it, then they get up to 834. And then I guess I could do one with the hundreds, but it just fits nicer. By pigeonhole and run out. Yeah. Fill in the acorns. Fill in the next 50 acorns. I feel like it was good by itself. Add the last 2 numbers next to it. Yeah, because it's a sequence. Specify each acorn. Yeah, so like this is the first one, the second one, third one. You don't have to be so... And that's another thing. They don't have to be so precise, because it's in fact a worksheet. A student sees a row, and they see ascending order, and they think, wow, I'm going to do it in order. And then they do it in order, and they do it right. Yeah, technically, like, they would get it. I've covered some, like, math worksheets with children, and at that grade level, they don't really have the most precise instructions. Yeah, it's not solved by mathematicians, it's solved by children. And the joke is that the children are getting bad. Well, technically, the gag is that adults would be doing it, but the joke is that all these are basically impossible. So, but again, children will sadly be the fodder to sate the ego of a mathematician. Doesn't need to be solved by mathematicians. Okay, what do you think about this? Should I change the order? So I can change this one in order. I can move it up. We could start with the math, the space one, the circumference one, so that people will think that it's possible to actually solve it, right? So on the very top, it's, yeah, circumference is the first one. Then your Fibonacci's would work. Cutting out the shapes is impossible. The Hilbert space is definitely not possible. Monty Hall is possible, so they need to know which is the best choice, right? This one I want to add a why or why not. So let's see. So what is it? Circumference? Oh, this entire thing. The whole thing right here. Are you smarter than a 5-year-old? Let me capitalize it. Yeah. Okay, are you smarter than a 5-year-old? So we have the Fibonacci's. After that, I'm gonna go up to the Monty Hall. Monty Hall should be the third one, or third one or second one. Because acorns, that's when you realize the bit's stupid, and then it gets worse. Back up here, Monty Hall with the icky broccoli. I think it should be number 3. Impossible should be last. Yes, okay. So the actual impossible ones, coloring page sounds really funny as the next like actual fake one you can't do. I think the biggest one would be the they're all good. Fibonacci's, cutout, or Hilbert maze is the last. Or is this order correct? So what's in order? 1 is this one. 2, maze should be advanced. Color cannot be last. Okay. So maze is last because it's impossible, and the gag will surely be done. At least if I imagine my daughter doing this. The coloring can come up before Fibonacci. Yeah. So you can do real math, dumb Monty Hall problem, coloring worksheet, counting. Counting's impossible because they get too big. But it's technically possible because that's funny. Then you have the cutouts. The cutouts are impossible because of the sizes. Oh, and then do you want to keep the rulers? I don't think I want to. Kind of want to censor them a bit. Yeah, Fibonacci's doable. Okay. So let me space these out again properly. And did these ones need to be different colors, do you think? Do you feel like they should be in different colors? Depends on the setup, really. Yeah, this one's possible. This one, I thought it'd be funny. So, yeah, may as well make it the same colors as the example. That's fine. 3 different colors. 3 different colors and it works. Yeah, my only last issue is this last one, this bottom one right here. Visually different colors to give, but it would give the answer right away. Yep. But you have to, that's basically like a, none of them can touch. Or is the instruction too arbitrary? Keep it all the same colors. Yeah, we don't need to. We don't need to visualize it. I do kind of want it to be a border. I think we're talking about triangle question. My bad. Yeah, triangle inequality. This one. Make sure the ends touch, right? Careful with the scissors. Don't hurt yourself. This is a dumb bit. This is like an extraordinarily dumb bit. I love it. Okay. Coloring page is fine. Excuse me. So then this one, I think that's it too. Just lock this in and GG. All right. Going once. Going twice. All right, ship it. Ship it. Ship it and ship it. Ship it and sip it. Okay, file. We are gonna export this. Okay, download as a. What exactly? PNG. All these are PNG. Compress the file 1 to 7 pages. Yeah, right? So there, it's not an MP4. It's not a GIF. Not a PowerPoint. We could make it a PowerPoint. PDF, good? Or PNG? PDF, best for printing. Let's see. Let's see how some of these come out. So when I download it, please don't show me my information. PNG, ew. Whoa, hold up there, bud. Okay, good. It's not showing any. I'm glad I have that cropped. Unless you want to post on social media on separate tweets or something, in case PNG is really good. I'll do it for my Twitter. And then maybe some on the YouTube, because I can make a post on it. Then this one, you guys can share that. I'll put this in the group chat. Should I give myself credit? I just realized. Should I give myself credit? This doesn't have my name on it. So, like, last page, I just realized. Did I credit myself alephmuvt? Duh. Okay, yeah, I guess so. Okay, back over here. Credit to... Okay, fix. And point people into your chat, of course. You guys were the real mathematicians all along. Okay. Should I say this was like a sesh? Come on. I mean, you do not have to. Okay, there we go. I know what happened. So it's in white. What color is it? Professional authorship. People won't take me seriously unless I'm a professional writer. Okay, what's the deal here, huh? I'm so smart now. Copyright a page of a book? Like a footnote? Yeah. What copyright? We took these off of the internet. Should I make it a title page or should I make it a credits page? Because the title page immediately gives me credit. But people sharing it around on the internet, it'd be funny. So here's what I can do. I already have a version of my name. Could be ACCR, and I doubt people would use it technically unless it's an April Fool's joke. Still, yeah. I would probably, post it on the... I don't use Reddit, but, post it on, r/math or something like that. Perhaps add small text to each page so they can share it independently. That's what the PNG sequence would be for, huh? PDF is the easiest to compile. PNG, if it was hosted on, let's say, a website. I think it's okay. Main thing I really want is just to, put my name on it somewhere. So I'll say text box right here. Who is you? Yeah. So let's crank this up. Size 32 font. alephmuvt virtual tutoring. Oh my god. It's just some fun, yeah. Don't inquire seriously. Okay. So we have alephmuvt. Alright, hold on. Credits? alephmuvt. Oh, no. Okay, here's what I want. I want to put it on the front page and be like, what to do. You know? alephmuvt is compiled some math problems that you can, to test if you can solve it. Is that it? It's not virtual. alephmuvt, math quiz, math worksheets. Are you smarter than a 5-year-old? Yeah, I'll do this. And then I'll use my chibi for this. Should be good. And that'll be it. Okay. Are you smarter than a 5-year-old? All works have copyright under Berne Convention, and that's not what I meant. Styling it in visual style as a copyright page. Well, okay, for us, we're good, because as far as I understand, the Canva license says anything is good as long as I'm not claiming it for monetization or anything crazy. Hi, Starry. We've just finished our stream. So now, next thing I need to do is upload my chibi at lowercase al, lowercase a. So I'm looking for my chibi. Yeah, so it's lowercase al, Aleph. Chibi, chaba, dooby, daba, daba. Magical, booby, dooby, boom, 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 boom. Okay. There we go. And it's something dumb like math is fun. And then I want like a background as well. So let me see. Copy this. Do this here. alephmuvt virtual tutoring. Should I do that? alephmuvt has compiled some really challenging questions. So should I even like set it up like that? No, right? Then I need a background. So math background. And then do parentheses. Yeah, I should. Oh, you can do equations. There's an extension. Oh. And then you're getting sent to the back layer. Okay, so here's the idea for right now. Do I need to adjust it? Does it look too busy? Where you grew up, tutoring is huge. So advertising as tutoring would guarantee hit? I guess it would, huh? Okay, I need these to be bigger. Some math problems. This is like the worst like compilation of it. alephmuvt has compiled some math problems. Even a 5-year-old can solve. Can you solve them too? And then let me lower the... And then what? Left hand justified? Oh. Can your 5-year-old solve this? Can your 5-year-old implies you hadn't sent them to tutoring. And technically it's hyphen 5-year-old or dash, right? Grammar. Okay. Which implies that they can't get... If they can't, you got to send them to tutoring. Doesn't really work with the title. Is that good? And then I have to say something like my handle, which is in place of the title if you've done it. Alternative title should say, because this is also in bold, isn't it? Well, yeah. So yeah, can you solve them too? 5-year-old. We're talking about 5-year-old children. Are they smart enough to do anything smart? I don't know. alephmuvt compiles some math problems. Even a 5-year-old can solve that even. I just want to make it a little thinner. Reduce the age by 1 each time. Even a 4-year-old can solve it. Can your 3-year-old do this? That's good. Oh man, that'd be so stupid. Would it be taken seriously though? Hold on. I mean, this whole thing is not meant to be taken seriously, so I guess it's a funny gag. For solutions, go to, yeah, okay. Ask. Okay, and then I just throw in my Twitch. And then it's a hyperlink, right? Can I add a... That works. It works. I don't know how it works. It just works. Damn it! How do I put a link? Comment more. Here it is. Link. Twitch.television. And if it clicks right. Okay. Even a 4-year-old can solve them. Can your 3-year-old solve them too? Okay, that's it. That's it. Safely strip off the www. Can I? Twitch.tv/alephmuvt, and then it should have a hyperlink. That looks good. Professional. And then right here, I need to have a text box with a speech bubble. Speech. Speech bubble. Can I spell speech right? Oh, it's an elements. Speech bubble outline. What should I say? Math is fun. I don't know about the decreasing ages. It's a dumb bit though. Serious front. It is the redundancy of saying it's the redundancy of saying 5-year-old funny. And then my little cowlick is sticking out on the top. Math is fun. This is it. This is it, guys. We did it. I didn't think today was going to be that pretty good. I thought it was going to be a little slow, but it looks like we got quite the bit of work done. And it works out well because it actually does seem kind of funny. The redundancy is too stiff. Okay. This is why I didn't want to go into curriculum writing. Math is fun. Big font. Big letters. I want a different font, maybe. Worst part is I learned something today. Dude, honestly, right? I didn't mean to learn anything too. Okay. Wow. Okay, so let's get rid of the... I like the redundancy. Can you solve them too? I'm just gonna do that. Can you underscore solve them too? Now this is set in Comic Sans. Should I put this one in Comic Sans? It looks pretty professional, all things considered. Comic Sans. Change all. Whoa there, buddy. Whoa there. Stop. Hold your horses. Should I all have been Comic Sans? Let's see how everything looks with Comic Sans, though. Ew. Ew. Okay. Okay, so that's fine. I think everything else looks fine. I do want to fix this last bit right here. alephmuvt compiled some math problems that even a something-year-old can do. That any kid can solve. Any kid can solve. Can you solve them too? Yes, this is going to be the cover page. And it has my link for solutions go to. And the joke is that there are no solutions. Or not necessarily the ones that you think of. Let's see. This is kind of putting me in like the family-friendly say-so kind of sector, though, isn't it? It's not that I don't mind being it. It's just I kind of want to like say some swear words. This is good. It'll be fine. It's fine. Yeah, no, it's fine. This is just for the bit, so of course. Alright. Is that it? Solutions are lost media after 14 days when the bot expires. Yep. What's the answer to pi? This one, wow. Divide it out. Kind of a redundant thing to do if kids already know what a pi is. I fundamentally don't cover. It's too hard. I don't think I even cover like adult content or grown-up content anyway. There's way too many things that people don't understand, and I feel kind of bad because I'm like, am I putting myself in a hyper niche? But the only way you can put yourself out there is to be a niche, and at least keep up with it, because that means people do understand your scope and they could always inquire about it. I'm not, like, math is such a broad field that there's no way that I don't know everything. There's no way I don't know it. I don't know everything, but people always want to ask about math stuff, and I'm not necessarily the one to want to cover math homework, but I can do it. I mainly want to cover like math, like journals or articles or stuff like that. Yeah, and I know right now math is also a very hyper niche field. So, I'm sorry, math is saturated with like content creators. So yeah, if I'm popular in my own niche, it'll work out. You know, Zach is making a quiz for kids, and it's not niche. Yeah, I know he invited me onto the newest quiz show that's gonna happen soon, episode 2 or something, but I can't make it because of time. So we'll have to I'll have to not join it this time, but I want to do one of the trivia nights. It's be really cool. And it seems like he does a lot anyway. Is he also, in fact, a faculty member? A director, if you will. Much like the pen. I'm gonna paste this in school if you don't mind. Do it. Do it. Do it. Do it. Do it. Do it. Okay, let me go ahead and make a copy. Real math folks have some Discord privates of their own. Yeah, huh. Basically, it's your own clique. So, hopefully or in general math. Yeah, so people appreciate the field. It's good. Okay, we're gonna download it as a PDF. You guys can send it everywhere, and then I'm gonna download them as individual pictures, and I'm gonna have a zip file, and I'm gonna post that both on my YouTube and my Twitter posts, and I'll have a section of it and maybe in like the art or math chat, one of the two. Okay, that said, I'm gonna go ahead and download this. This is done for today. Are you smarter than a 5-year-old? Wow. Help find the best ratio. Calculate the best answer in decimal. Yep, very cool. Monty Hall problem, very good. Coloring sheets, Fibonacci's, cutouts, because it's fun. And then a Hilbert space maze, and that's it. I hope people get these jokes. As what, 1, 2, 3, 4, 5, 6 jokes? That's good enough. That's fine. So that's it. Let's go ahead and find somebody to raid. Let's see if we can bully anybody. Thank you guys so much for coming in today. I didn't expect, you know, I know today was super busy with like the space and the things and everything's going on. Lots of things were going on today, but I guess this time, right now, localized entirely inside of our browser. Can I share the PDF in the raid maybe? If we find someone who is available. Science stream is on. Shindigs, no. I'm too small. Pen is on right now again. No wait, you guys are watching it here, right? No, he's playing Zelda. He's playing the randomizer Zelda stuff, so let's see. If we can find someone, I have no one. Tell me if you happen to know anybody. Maybe somebody who's doing a just chatting stream. So that they have the downtime to like do stuff. How would I send them the PDF though? I just like join a Discord and just be like, hey, click this link, buddy. Let's see. Upload as a link. A shareable link. How do I do that? Here, let me put it in the chat in the Discord then, and then you guys can show me how you got it. So let me put that in right here. This is the PDF. And then just to be extra safe, I'm gonna cover my screen. You can't see nothing. Where is this at? Okay, delete this one. It's in my cave story cosplay folder of all things. Okay, let me put it in and you guys figure that one out. In the meantime, let's find somebody. I'm really the best at planning, huh? So if we were to rank somebody, let's find someone real quick. You could always just go back to Pen and bother him. If you got no one, let's see. Hangout and drawing stream. Birthday stream. Happy April. Drawing. Oh yeah, because I'm in the art category. Safe fallback is good. Let's get ourselves out there. Some people are actually just drawing in chat, and it'd be nice to just see some other like VTubers doing some nonsense. Let's see. Furry. Let's see. I'm trying to go for someone who's relatively normal. And excuse me for that. They'll likely appreciate the link too. So let's see. We're gonna go for... looks like there's one... There's a Cantonese streamer I want to try. So maybe we can do... She's doing a HoloLive art thing. So which is cool. You guys want to do that? It's JVT. It seems to be a HoloLive fan artist with 20 viewers. Should be good. Okay, then we'll do that. If we can get a shareable link, do we know how to get the shareable link yet? He was gonna suggest JVT. You know her? Okay, good. Then this will be good. Then, do we have a link yet? Do we have a link? Can I get it back here? Copy link. If I post that, is it accessible? Oh, Lord. Also, this is the part of rating that I don't know what to do. So... Oh, it's a download link. So yeah, I guess it works. File.io should be good. That'll be accessible if the link expires for PDF directly. Or downloads works then. Yeah, I just don't want to be rude about it, you know? Perfect, ignore it. Okay, fine. We'll do the shareable link, the Discord thing. Okay, well, let's go bother Jay. And do we have a raid message? Oops. Alright. We're going in 5 seconds. So, goodbye guys. Love you. See you next stream. Bye-bye. 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 Let's go. I don't know. Yeah, that's good. You're smarter than a 5. Yo-ho. I am. Yeah. Load, 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 load. Okay, I'm missing valuable time. Okay. Sorry, super lagging my end. Did you like the link? So much. Oh my gosh, let me... It's the link to the map I made. Yes. Yes, 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 yes. Yes.